This is Jordan Lang for Assignment 3 for ItDev154. This was a long one. Holy cow. Had I known, kind of what I know now, I more than likely would not have put it in a single file. I would have created separate files, as this is probably one of the longest single programs I've ever written. But let's get started. So, this is my implementation of a singly linked list. The program, when ran, will display, and you will see it running, which is why this is going to be a long video, so I do apologize for this in advance. We're going to start with display. So I created a simple menu system to kind of handle all the different functions. This was just kind of the easiest for me rather than create something fancy that I had to troubleshoot, as I'm already troubleshooting this monstrosity. So basically it goes into, so each of the options go into the individual requirements for the assignment. Everything from bubble sorting to inserting to removing, counting the cycles, counting how many nodes, etc. But now for, I guess, the meat portion of this video. So you have your initial. So to set up the node, you have to have your class node. This public int info. So this info is the name of the data stored in the list. This int does not have to be an int. It can be changed to any variable type. So it's not restricted to just ints. I made mine ints for my own brain simplicity of this. So link in this refers to the next node of the list. Uses a constructor. It to initialize the link. Start is the way I have referred to the first node of the list. That seemed the kind of best. And then obviously, since the beginning of the node will not have any links, it'll be null. Okay, so for the display list, it literally just displays a list. It uses it first checks if there is a data point, which this was kind of irrelevant in the program, as the way I wrote it, the whole program starts with you creating the list, so there is no kind of there is no way that this could possibly fail, but it's in here. It then goes through and displays the list, displays all the info, line by line. Not really a lot to it there. Count nodes. Starts by initializing. Starts at the beginning, and then while the next node is not, while the node is not null, it iterates through the loop and just keeps counting until the P node has no link. Sorry, my watch was buzzing. And then at the end it states how many nodes in the list there are. Search returns as a bool. I had it return as a bool because I wanted to, if the node was found, then I want to return that the node was found. If not, then I don't. then I want to inform the user that it was not found. So starts at the position 1 of the node, and while it's null, as long as there is data, it will keep going. It'll add one of the position. It basically loops through it, looking for the X value. If it's not found, it'll state that it's not found and then return false. If it is found, it'll state the position that it's found and return true. Insert at the beginning is just a simple node. It's a simple method that just literally inserts the data from the new node into the beginning of the list. There really isn't a whole lot to this, sorry. Insert at the end does exactly what it states. It inserts a node at the end. So if the list doesn't exist, it'll still run because of the fact that you can, even without a list existing, you can still insert things at the end, because technically if you're only inserting one node and an empty list, that is the beginning and the end. So inserting it one way or another doesn't really matter. This create list method is ran at the very start of the program. Has the user enter how many nodes they want to create, and then iterates through a loop and has you input the element to be inserted. So in my case, to keep things simple, I used 5 numbers from 1 through 5, obviously not in an exact order, so that the list would be scrambled when initially put in, so that things would show as that it actually sorted rather than, was put in sorted. This insert after takes in the data point that's inputted from the case switch down at the bottom, and where it's going to take a data, so it takes in the data node that the data is in the node that's being inserted. It also takes where you want to put it. Again, if it's not present, so if you try to enter a value that's not in existence, then it will not let you do that. Other than that, it will move the node to a temporary, put it in, and do its replacement thing. Insert before, same thing as insert after, except it inserts after. If the list is empty, it obviously errors out. So if X is in the first node, then the new node will be inserted before the node. So it's passed in X, so X is the node that is passed in, it inserts. It also has to, because it's inserting before, it has to recreate that link. Again, if there's nothing there, it states that it's not there and errors out, but it inserts. Insert at position is, again, very similar to these. It takes a argument of the data point you're trying to enter and the data point that you are where you're trying to put it. If the where you're trying to put it is at the very low number, then, or at the beginning of the list, I should say. Loops through it, inserts it. If it's not found, you can only insert up to the position that the list has. Delete the first node. So if the start is null, it will. If there is no starting null, which means the table hasn't been created, again, it won't happen because in the program you've already created it. Then it will take that, then it'll delete it. Deleting the last node, so if there is no first node, and it will return. If there is a node after the start, then it'll make the start nothing and return it. Yeah, pretty straightforward. Delete node, it deletes a node. If it's empty, it'll tell you it's empty. It will obviously take an X, which is the node you want to be deleted. If the start of the list info is equal to your inputted deleted node, then it will it'll make that node, the starting node, the next link. This is a big project. So this would delete the first node. This section would delete if it's in between or at the end, or if it's not found. Reverse list just does a lot of, so it has previous node, next node, and current node. So if it says the current node to start and just basically loops through and kind of just shuffles them around in fours until they're all reversed. Bubble sort sorts it, so for however long the last node is, yeah. Bubble sort links. Yeah, this is not my strong part. I had to look up a lot of this, and I'm still not 100% how code really works for bubble sort. It does work, but I need to do a little bit more reading on how this exactly works. Cycles, so it inserts a cycle, it'll scan the list, it'll assign the value, if the data is found in the list, points to the last node, and if the data is not found. That's how it inserts cycle. Has cycle simply just refers to find cycle, and if there is nothing in there, then it returns false. So find cycle. You talked about this with the tortoise and the hare, and I kind of understood it, but on this data structure is kind of a nightmare for me right now. They kind of race is the way I was to understand it. And that's how it finds it. So it advances each node by one, and then whichever one hits it, then Yeah, else it returns slow. Removes a cycle, so does the opposite of what the above one does and just removes a lot of it. That's all I really have. I guess we can take a peek at it. So, like I said in the beginning, it starts off with having you enter the number of nodes. I have edited this so that it shows what a human would think. So if you want 5 nodes, it's going to start at 1. I don't know. I know that's how coding is supposed to work, but I was just a little weirded out that if I were to put in 5, it would actually ask for 6 nodes. So let's put some nodes in. So 3, 2, 5, 4, 1. Okay, display the list. The list is 3, 2, 5, 4, 1. Obviously, that's the list. The number of nodes, the number of the nodes in the list is 5. So obviously there are 5. If we display list, there are 5 nodes. There are 5 number of nodes. Search for an element. I want to search for the number 5. 5 is at position 3. Let's check that out. Display. 3 is at 1. 2 is at 2. 5 is at 3. So that would be correct. I want to insert into at the beginning of the list. So at the beginning of the list, I want to enter 0. So if I display the list, and I have now 0 through 5. If I want, so I want to insert a node at the end of the list. At the end, I want to put 6, just to kind of keep with my 1 through 6 method. Again, if I display it, there's my 0 through 6. Obviously, 0 and 6 are in the correct positions, but none of the other ones, well, 2 technically is, if you include 0 through 6. So sure, that works. Anyways, so sorry. 5. So, end of the list. Okay, that's where I was. Sorry. Insert a node after the specified node. So, I'm going to insert 7 after the 3rd node for giggles. So if I show it, it'll show that now 7 is at the 3rd. I'm going to insert a node before a specific node. Sure, why not? Let's do 8, just to keep it in line. And I'm going to put it at the 3rd spot, just for fun. There's our nodes. Now we have a list linked list. Given position. Okay, deleting the first node. 9 simply deletes the first node. Delete the last node. So if I were looking at this list, 6 should be deleted. 10, no, it was deleted. 1, 6 is gone. Delete any node. I'd like to delete 0. Let's remove 7 because that's kind of the outlier. And there's our 1 through 5. Reverse the list, sure, why not? 12 just reversed the list, as you can see. Prior it was 3, 2, 5, 4, 1. It is now 3. It is now 1, 4, 5, 2, 3. The list is now reversed. Bubble sort by exchanging data. It is now sorted, as before it was not. Let's see, we have to re-scramble it, so that is 12, so 12 12 to slightly scramble. Then we're going to 14 it again. Uh-oh, it doesn't look like my 14 works. Hold on a second. Apologies, there appears to be something wrong with that. So, right now we have a displayed list, so we have a re-scrambled. So we're going to bubble sort it, and again, it's now organized. 1, 2, 3. I put whoopsies. All right, well, it's supposed to be like that. Oh yeah, because I put 2 3s in. Okay. So we're gonna insert a cycle. Let's insert the element 2. Wow, what is going on? So my bad, that's apparently what it's supposed to do. That's why I'm not too exactly sure. So don't display that, just detect it. Again, recreating our set, so we'll reinsert the cycle at 5. We will detect the cycle. The list does in fact have a cycle, as was shown in the displayed list. That's why it kept looping. So that would explain it. And then 18 will remove the cycle. The cycle was detected and removed. So, and that's kind of it. Sorry for the long video and sorry for the long rambling. This was a very long first assignment. Have a good day.